Beyond the Osprey, DARPA wants a high-speed, vertical takeoff X-plane. The Defense Advanced Research Projects Agency is working with 4 companies to design an experimental vertical takeoff and landing aircraft that can fly at speeds far exceeding those of the V-22 Osprey. The collaboration comes as the U.S. military studies how it could operate aircraft in areas that lack traditional landing strips. DARPA calls its program SPRINT, Speed and Runway Independent Technologies. In November, the agency awarded contracts to Aurora Flight Sciences, Bell Textron, Northrop Grumman and Piasecki Aircraft Corp. To begin refining their ideas. The total value of these 4 contracts, which cover the initial phase, could amount to between $15 and $20 million, depending on the options exercised by the agency. By spring 2027, DARPA wants one of those companies to have finished designing and prototyping its plane, built it and made its first flight. Navy Commander Ian Higgins, director of the SPRINT program, stated in an interview on December 15 that speed is one of the key requirements for this aircraft. When the SPRINT aircraft flies forward, DARPA wants it to reach speeds of between 400 and 450 knots, or between 740.8 and 833.4 kilometers per hour. The V-22 Osprey has a maximum speed of 270 knots, 500.4 kilometers per hour. What we want to achieve are higher speeds, Higgins said. We are going to exceed the Osprey's 100 knots, which is already a physical challenge if we use the Osprey's propulsion system. Higgins said the SPRINT aircraft must also be able to glide and be stable during the transition between hovering and forward flight and have a distributed power system during that transition that effectively powers all propulsion systems. According to Higgins, SPRINT does not focus on the survivability or potential payload of these concepts. When it comes to achieving these goals, DARPA leaves a lot of room for maneuvering to competing companies. For example, companies can decide whether their aircraft should be crewed or unmanned or whether they should fly autonomously or semi-autonomously. Right now, everything is very varied, says Higgins. The concept images released so far suggest the range of strategies companies could employ for their SPRINT proposals. In a statement released November 27, Bell Textron showed off a tiltrotor design similar to the Osprey on an apparently unmanned aircraft hovering over a platform at sea. Bell said its SPRINT proposal will combine the hover capability of a helicopter with the speed, range and survivability of a jet aircraft. The company also plans to build on its previous work on high-speed VTOL technology. Bell is conducting risk reduction testing of its folding rotor, integrated propulsion and flight control technologies at Holloman Air Force Base in New Mexico. Boeing subsidiary Aurora said in its own statement that it is designing a high-lift, low-drag fan-wing aircraft that uses a mixed-wing body and integrated engines for forward flight, as well as integrated fans attached to its engines for vertical flight. The concept image released by Aurora shows the proposed mixed-wing body for its aircraft, which is not far from the design of the Boeing X-48. Aurora says he is also using ideas from his Excalibur unmanned aircraft, which uses vertical lift by jets with electric fans that retract into the wing during forward flight. The SPRINT contracts awarded so far cover the initial conceptual design phase, lasting 6 months. By May 2024, the companies will have to convince DARPA that their concept will work and can lead to a first flight in 2027. At that point, DARPA will eliminate at least one challenger and move on to the next 12 to 15-month phase. At that point, DARPA hopes the companies will have completed their preliminary design, and the field will be narrowed further. According to Higgins, the possible uses of high-speed vertical lift aircraft are very broad. They could be used by special operations forces and for mobility and logistics operations, personnel recovery, medical transport and evacuation missions. He added, anything that requires an aircraft to enter and exit unusual areas quickly. And in a future war, Higgins said, the military might need planes capable of taking off and landing from streets, open fields, cratered flight lines or other places without traditional runways, and then quickly zoom away. It really opens up the possibility of being used in all of those missions, Higgins said. Right now, the technologies that would be used in SPRINT are not intended for any existing projects. Higgins acknowledges that the project may not come to fruition, but he hopes the technology can one day be incorporated into an existing program. The nice thing about DARPA is that we pose difficult problems that may or may not be doable, and we see what the current state of the art is, explains Higgins. Thanks for watching.